Hey, what's going on, everybody? So today we're going to be evaluating functions. Here's your LO and your DOL. The TEK we're working on today is going to be evaluate functions expressed in function notation given one or more elements in their domains. And so we're going to start off first by identifying what is a function. So when you're going through the slides, make sure you click on this video. It's going to be a little wrap about functions. Now, looking at what is a function. So basically, if you were to define it algebraically, it's going to say every element in the domain has only one range value. Now, what that really breaks down to, this part basically says every x has only one y. So you gotta make sure every x has only one y. Now, back in middle school, you learned about the vertical line test. So if I were to draw a vertical line going through any x value, so if I were to say this right here is 1, so I'm gonna write 1 right next to it. When I draw a vertical line going through 1, how many times does the vertical line cross my graph? It only crosses it once, so that means for this particular graph or function or relation, it has only one y value. And so if I were to draw an infinite amount of vertical lines, you could tell that it's always going to cross just one. So this is a function. Now when we come over here, I'm going to draw a vertical line. And if you notice, how many times does it cross? It crosses twice. And since it crosses twice, that means it is not a function. Now, there are some exemptions to weird-looking graphs.
It is now the beginning of D-Lunch.
There are some exemptions to the way graphs look like. So again, you gotta do the vertical line test. That's the first dead giveaway. Now you come over here though. Notice that this graph has what's called an open dot, but it's technically a hole. Now, if you notice here, there is a solid dot, meaning that there's actually a point there. So this one means not included. This one means included. So this one is not a solution. This one is going to be part of your solution. So if I were to draw a vertical line going through it, technically it goes through the hole and then lands on this point right there. And so that means if I draw a vertical line anywhere here, there's always just one point. The point being right here, and so everything else is still good. So this is a function. Go ahead and pause the video real quick and tell me if it's a function or not function in your own work. All right, guys, now that you had enough time to, after you just pause the video, this will be a function. Because if you draw a vertical line everywhere, it only crosses once. But then if it's not a function, the technical term for that will be a relation. And so this one, even though it's just coordinates, if I draw a vertical line, that one's good, that one's good. But you notice here when I drew a vertical line going through x's equal to 0, I have 2 points that are right there that break it. So that is a relation. Over here, automatically it is a relation. This one might be a little iffy just because of the way it looks. Now this line looks like that, and this one almost looks like it's going vertical. But if you were to draw a line and zoom in very closely, you will notice that this is also still a function and that it is slightly going to be going to the right and up. Same thing here. If I draw enough vertical lines and I zoom in close enough, this is also going to be a function. All right, here's your vocabulary. Now, what we're going to be doing is we're going to be moving away from y equals. So this is the terms that y'all used back in middle school, but here we have function notation. And so essentially, this is y, this is f, and this is your x. Now, if you want a chart of a breakdown of everything, so x, f of x, middle school, x and y. This was your input. This is your output. Algebra terms are going to be, this is your domain, this is your range, and there's a couple more other terms we could use, such as independent variable and dependent variable. But for now, this is what we need to know for right now. And so anytime you see f of x, you could basically interpret it as meaning y. But this is special though. And so when we move on to this actual problem right here, we have f of x is equal to negative 4x plus 7. Now, if you notice, it says find each value because we're about to evaluate, which is f of 20. And so I'm going to use that. And so I'm going to color code it at this point now. So I'm gonna go ahead and stop right here and explain something. One, we already know that this is our input. This entire thing, the function notation, the f of x represents the output or your range. And so f of x equals negative 4x plus 7. That's saying that this equation, f of x is equal to negative 4x plus 7. That's the name of it, f of x. Now, if you notice here, what changed? And so if you already thought about it, you notice that this x has now become a 20. And so with that being said, whatever is inside these parentheses such is going to be your input. So this 20 is going to be substituted into every place where there's an x. So hypothetically, if there was more x's here, all those x's will become 20 because that's what it's asking you to substitute into your variable. So there's an x right there, so that says negative 4x, which is 20, plus 7. Now at this point, you could just continue with your work. Negative 4 times 20, that gives you negative 80, plus 7. And at this point, you could go ahead and simplify, use your order of operations. F of 20 is going to be equal to negative 73. And so you could come over here and write equal to negative 73. Let's go ahead and do a harder example. And so if we look at B, that is a two-parter. And so we're going to do the first part first, which is this right here, f of negative 3. So I'm going to do f of negative 3. Well, first off, I'm going to go ahead and erase that real quick. Now I'm going to start from the very beginning, f of x. And so we're going to use the original function again, 4x plus 7. Now, they gave me negative 3 to use. And so again, this x became negative 3 because that's what the problem told me to do. And so I changed all my x's to negative 3. And then from there, I just do order of operations. And so negative 4 times negative 3 is going to be positive 12 plus 7. 12 plus 7 gives me 19. So f of negative 3 is equal to 19. But I'm not done yet. If we go back to what B says, it says f of negative 3 plus 1. So I'm going to say this is step 1, step 2. We go back and we're going to substitute what we have into our thing. So f of negative 3 plus 1. F of negative 3 becomes 19 plus 1. And we got the 19 because that's what it says right here. It says f of negative 3 is equal to this number. And so I could change those interchangeably. So this becomes a number, which is 19. 19 plus 1 gives me 20. And so f of negative 3 plus 1 is equal to 20. And so I'm going to go back and recap all our steps. So the first one will be basically to substitute. 2, you're going to evaluate. And you're going to evaluate the equation at this point by simplifying. Let's see if and just remember your order of operations. All right, so that is the I do video at this point. And so if you want to go ahead and do one yourself, so that way you know what to do, go ahead and pause the video and work out these problems. And that will be the wrap of the video after I'm done showing you. So go ahead and hit pause. All right, guys, that's the end of the video. Thank you for watching.